Let's start by looking at just the basic structure of the vertebra. This is the anterior side of the vertebra. This is the body of the vertebra. So this is the place where the vertebral disc sits. On the posterior side, you have a spinous process. Out to the side, these are called the transverse processes. There's a little bridge right here between the body of the vertebra and where the transverse process is. This is called the pedicle. The pedicle connects with the lamina, which is this small plate-like structure right here. The lamina and the pedicle together make up the vertebral arch. So this vertebral arch is going to surround the spinal cord. Each of the vertebrae are going to attach to each other by articular surfaces. So right here, this process that is sticking up has a smooth surface to it, which will have hyaline cartilage on it, and it will attach to the vertebra that sits on top of it. From the underside, the inferior view, we also have articular surfaces right here and right here. And this is where the vertebra from underneath will attach to this one. There are other articulating surfaces as well. So on these transverse processes, you can see this smooth surface right here. This is also an articular surface for attachment, but this one in particular is for the ribs. And I'll talk about that more when we talk about the thoracic region. The superior-most region of the vertebra is called the cervical region. The cervical region starts with a couple of really unique bones. C1, also called the atlas, is the very first one, and this attaches to the skull, so it has superior articular facets on these what are called lateral masses for the connection of the occipital condyles. So the head, the skull, rests on these two surfaces. This is the anterior side, this is the posterior side. So this is your posterior arch. This is your anterior arch. The other thing that you might notice about this is that the transverse processes have holes. These are called transverse foramina. Foramina is plural for foramen. And it has a very large vertebral foramen. Atlas, or C1, sits on top of C2, also called the axis. On the axis, you notice a really unique feature. This projection pointing superiorly is called the dens, or the odontid process. It also has superior articulating facets on either side. And it has a posterior arch. The axis has very small transverse processes, but it still has the transverse foramina. This odontid process, or the dens, allows for the atlas to rotate on the axis. Other identifying features of the cervical vertebra include the spinous process, which is forked. This is also termed bifid because there's two parts or two smaller processes that come off of it. The bodies are relatively small when you're looking at these compared to the other regions. All of these have the transverse foramina. All of them have superior and inferior articulating facets. And there are 7 of these. So when you're looking at the cervical vertebra, a couple of things that you can identify this particular vertebra by. The spinous process is forked. All of them have transverse foramina, and the bodies are relatively small. The next region of the vertebral column is the thoracic region. The thoracic region, again, has a body in which the vertebral disc would rest. It has an opening for the spinal cord, the vertebral foramen, and on the posterior side, it also has a spinous process. Out to the sides, it has transverse processes. But note that the transverse processes don't have the foramen. There are superior and inferior articular facets, and this connects upper and lower vertebra. These also have other facets called costal facets. Costal indicates cartilage or ribs, so we're talking about attachment sites for the ribs. On the transverse process, these smooth surfaces out to the end are called the transverse costal facets. There are also 2 others. One right here, which is very small. This is called the superior costal facet. And then one down here, which is called the inferior costal facet. So each of these 3 places are connection sites for the ribs. Putting 2 of the vertebrae together, you can see a hole along the side. So we know that the intervertebral disc would go right here. This is an intervertebral foramen. So this is a hole. This allows for spinal nerves to pass from the spinal cord and go out to the anterior or posterior part of the body. You can see the notch for it down below. Many of the vertebrae in the thoracic region have an elongated spinous process, and some of them point downward. The next region of the vertebral column is the lumbar region. The lumbar vertebrae have a really large body. They also have a spinous process, but it is blunt and looks kind of boxy. In order to make connections with the vertebra above and below, they also have superior articulating facets and inferior articulating facets. The lumbar vertebrae do not connect with the ribs, so their transverse processes do not have a costal facet. There are 5 lumbar vertebrae. The sacrum is a bony plate that forms the posterior wall of the pelvic girdle. It was named for its prominence as a large and durable bone. It's made up of 5 vertebrae, and as we age, these fuse together to form this one triangular bone. So by the time you're a teenager, these have all fused together. The large prominence up here is called the promontory. This has a vertebral disc which sits on it, and then L5 from the lumbar region sits on top of that. It makes its connection with the articular surfaces right here. Down through the middle is where the spinal nerves would continue to pass through. These would pass through, and some of them would pass through the anterior sacral foramina, going to the anterior side of the body, while others would pass to the posterior, through the posterior sacral foramina. This bony plate also has a ridge right down the middle. This is called the medial sacral crest. On either side of it, there's a smaller ridge called the lateral sacral crest. In this view, you can see these little wing-like structures sticking out. Those are called the alae. That means ear. The ala has a surface, an articular surface, which makes its connection with the rest of the hip bones. And that will form a joint called the sacroiliac joint. This surface is called the auricular surface. At the very bottom, this is a surface in which would connect the coccyx, which is our next region. There are 4 tiny coccygeal vertebrae. They're fused together by the time you're in your 20s and 30s. They're also known as the tailbone. And they have little tiny horns that project up from them, which generally connect ligaments and hold it in place to the sacrum. I want to do a little bit of a comparison to help you better see the difference between the lumbar vertebra and the thoracic vertebra. So if you look at these processes which have the articular surfaces, you'll notice on the lumbar region that the vertebrae have their articulating surfaces pointed inward towards each other at the superior view. At the inferior view, you'll see that these articular surfaces point outward. But when we look at the thoracic region, the vertebra, their articular surfaces point posteriorly, and in the inferior, they face superiorly. So those projections, those processes, they change their orientation. And that's one way that we can tell the difference between the thoracic and the lumbar region of the vertebral column.